Using functions to model relationships, worksheet 15, questions 18 through 20. The graph below shows the height of a balloon during the first 30 seconds after it is released. So you're holding a helium balloon and you release it, and what the graph shows is what happens to that balloon the first 30 seconds after it is released. So for question 18, they want us to write a linear function that models the situation. Remember, write a linear function means write an equation. So we're going to write an equation for this graph. This is not anything new. We have taken graphs and found the equations for them many times. And in order to write an equation, you must find your slope and your y-intercept, your m and b. Remember, y equals mx plus b. Y equals mx plus b. So we have to find the slope, which is m, and the y-intercept, which is b. All right, so the easiest thing to see when you're given a graph is your y-intercept. So right there is where the graph intercepts the y-axis. So that is our b. So b equals 10. The next thing we need to find is our slope, our rise and our run. Well, a lot of people want to use this point right here as one of the points on the graph, but it actually doesn't go through the grid line. I guess I should have made the line thinner so you could see that. But that's often a common mistake. So that is not a point that goes through the intersection of two grid lines. So we don't want to use that to find the slope. We're actually going to use the point that we just made there for our y-intercept, and then we're going to use this point way up here at the top. Those two are the 2 points we're going to use to find our slope. So let's start by finding the rise. I'm going to draw my line down. Let's make it a little thicker. You should be drawing this line on your graph too. And then my run, the line for my run, I'm going to make that a little thicker. So I need to find my rise and my run. Now, before we started, I actually filled out the grid lines. A big mistake people want to make is they want to count 1, 2, 3, 4, 5, 6, 7, 8, 9, and put that the rise is 9. But that's not actually the case. Okay? You have to go by the grid lines, and the grid lines, excuse me, are going by tens. You see I already filled out the numbers 10, 20, 30, 40, and so forth. So for my rise, it is actually going from 10 up to 100. So 10 up to 100, 100 minus 10 would be 90. So my rise is 90. My run goes from 0 to 30. My run goes from 0 to 30. Well, 0 to 30 would be 30. So my run is 30. So now, given the information we just found on this graph, we can now find our rise, our rate of change, which is our slope, and our initial value, which is the y-intercept. So the rate of change, which is our slope, that is our rise 90 over our run 30. If you divide that out, what is 90 divided by 30? That would be 3. So if you look over here, it's feet and seconds. So our rate of change would be 3 feet per second. The balloon is rising at a rate of 3 feet per second. Our initial value, our starting point, is right down here. That would be 10. It starts at 10 feet. All right, now using that information, you have your m and your b. Go ahead and write an equation for this situation. Put your m in front of x, your b behind x. Okay, now that you've written your equation, we're going to answer 19 and 20 together. It says, what does the initial value of the function represent? This is where I really wish we were in class, because if we were, I would discuss this with you. If you look at this, it says 10 feet. 10 feet is our initial value. What that means is you're holding the balloon. If you were holding a helium balloon, would the balloon be down on the ground? No, it usually hits on a string, right? And it would be up in the air. So that means that the 10 feet is the height of the balloon before it is released. The height of the balloon before it is released. And that is our answer to number 19. Whoa. Let's try that again. So the initial value is the height of the balloon before it is released. The rate of change, the 3 feet per second. The 3 feet per second. Think about this. Your balloon is, since it's a positive slope, your balloon is rising, and it's rising at a rate of 3 feet per second. So the rate of change is the number of feet the balloon rises per second. The number of feet the balloon rises per second. And that is it for number 20. If you have any questions on 18, 19, and 20, and don't forget to finish writing your equation for 18, if you have any questions on these three problems, please do not hesitate to ask.